Thank you. So yeah, hello everyone. Welcome. Thank you so much for coming to the talk. Really appreciate it. So yeah, basically we're gonna be talking about securing AWS environments with Terraform, Vault, and Veeam, which is some pretty cool tools. And we're gonna do a live demo, time permitting, either with Terraform Vault, and then if we have time with Veeam. So this is basically the agenda. We're gonna be talking about securing especially secrets, tool overview, the architecture of what we're gonna be handling, a live demo, best practices, and then wrap up and questions after that. So a little bit about me. I'm Nick G. I'm originally from Colombia. I'm the father of two children. I'm happily married. One of them is a newborn that was born a month ago, and I'm already starting him on HTML for babies, which I really love that book. It's pretty interesting. I'm a board game aficionado, so if you guys love board games or have any recommendations, I'd love to chat about them. I have around 60 board games in my house. They're amazing. And my main stack, or what I love, honestly, talking first, is React. I love the cloud and I love doing stuff for mobile. I've been doing this for 15 years and honestly, I just love doing this. So why this talk? I'm actually talking about experience or stuff that really happened to me. So around 7 years ago, I got a comment on GitHub public repo, something like this. Looks like I accidentally leaked one of the secret of that database password, and thankfully a white hacker caught it, and he just sent it to me. And honestly, I started panicking. I was working for a US remote company at the time from Colombia, and I honestly was a first for me, and I have no idea what happened. But it's a common practice that is starting to happen more and more about secrets or stuff getting leaked, either on Git repositories or getting leaked somewhere, API keys or whatever. For example, this is something that happened with Mercedes. They had a GitHub token accidentally uploaded to a public repo of libraries that they support, that they're open source, in October of 2023. And it was 5 months before somebody actually discovered it. It was discovered by Red Hat Labs, which is a security firm that is honestly pretty amazing what they do. They disclosed it to Mercedes, and Mercedes confirmed the leak and revoked the token. But it literally took around 6 months for it to be discovered. Imagine how much info was leaked, everything that happened. So basically what we're gonna talk here is about how to secure that on the easiest, fastest, best way possible. Why is this needed? So basically, secret sprawl, hard-coded AWS keys in repos or pipelines will lead to accidental leaks and breaches. At first, I personally started coding in PHP and other languages. We used to hard-code stuff. PHP is an awesome language which you can do a lot of good or bad stuff because if you don't follow the standard. So that was pretty common, honestly, to do, to just hard code stuff there. But right now with this new React, with these new frameworks, with everything that is happening, this can happen on the pipeline. So if you use Vercel, if you use any of these other platforms to deploy, you actually need to set up your secrets. And it's very easily for them to get leaked or something. We'll look at that in the diagram a little bit later. The other stuff is manual provisioning and drift. So why are we gonna use, for example, for our cloud infrastructure? Basically, once we start, let's say, for example, AWS, you create your account, then you go into EC2, I'm gonna create a server, you go to Lightsail, you go into something, but everything manually, it's really hard to track what you're doing. You end up writing the PEM key, or I'm gonna just use a password. Everything becomes a little bit harder when time goes on, and it's easy to get misconfiguration. So with this tool that we're gonna use, basically it helps us version everything on GitHub, and it works honestly wonderfully. Even for small projects, I started using it for, I don't know, I need to deploy a WordPress server for something that I'm doing, and it just works, and it becomes easier, and especially to manage. There's also a backup gap, because imagine you can rely on AWS snapshots, even about secrets or whatever, but they don't have a policy, they don't have ransomware protection, which is something that can happen, and I'm also coming from experience on this. And the last thing is compliance and audit pressure. So when you try to get new, compliance or the ISO 9001, sorry, I know the name Spanish, not English, it's really hard and you're basically gonna fail if you don't have any of this, the first thing they're going to ask you, where are your PEM keys located? Where are your passwords? Where's the database password? And if you have them, no, we have them written down, we have them in AWS secrets or whatever, you're going to get failed it. So this is the easiest way, honestly, and the fastest way to get it passed. And right now, with the age of AI, basically, this is something that we see a lot. If you run this query on GitHub, you're going to see people that accidentally put their OpenAI key with all these new byte-coded apps and everything, and they basically get leaked. Somebody grabs them and can ramp up thousands of credits in hours. We sadly had that happen once. So, like I'm saying, coming from experience, and it's not fun. Thankfully, OpenAI has, they forgive you one of those life cycles if it wasn't that much money spent. So it happens. So the tools, what I honestly wanted when I first saw this, and especially being most front-end heavy developer, mobile heavy developer, how can I automate this, which will be the easiest, the fastest way, honestly, and the most robust. So Terraform, honestly, was infrastructure as a code. You can create a server instead of going, through EC2, configuring the VPC, configuring a lot of that. It does most of that stuff either automatically for you, or you just do it on some lines of code. But it's literally 4 to 5 lines of code. So for me, it was the most consistent and had the best repeatability. So if you needed to duplicate your infrastructure in another zone, you needed to move even cloud providers, it was super easy to move. I also like Vault. It's from the same person who bought or licensed Terraform, HashiCorp. And I love it because they have a free and open source, really, really good version of Vault that honestly, you don't need the paid one unless you're a super enterprise. So they have for small, medium, large companies, solo projects, and you can just deploy it on any cloud provider for like $5 per month, or even running it locally like we're gonna run it. And Veeam, last, is a great product where you can do a backup of the backup. So with Veeam, you're literally ISO compliant for all those certifications. It backups everything into an RDS instance, and it does it automatically against ransomware, against everything. So it's basically a win-win. So right now, because due to the time constraints, we're gonna focus on Terraform and Vault, and we're gonna try to see if we can squeeze Veeam in or just look at the configuration. So yeah, like I was saying, a little bit of Terraform. It's a declarative way to define AWS resources. You can define almost everything, users. You can enable version control, so you can see on GitHub what happened or whatever, or you're in a Git. And it eliminates manual console setup. I honestly loved AWS manual setup, like going through the console. It make me feel, I don't know. Right now, I personally dislike it. With this, it's so easy to create something and to destroy it with one command to save money. So I just go with it, and integrates with Vault and Veeam modules natively. You don't have to do anything. So a little bit of what Terraform does. You got templates, scripts, policies. You put it through Terraform, and you can configure the network, security, application, cloud infrastructure, and storage. It's that easy. It has full power. You just need an AIM secret, and that's it. And Vault, it stores sensitive data. So I want you to think of API keys, secrets, DB passwords. It stores everything on an easily, securely way that just works. You can also have dynamically short-lived credentials. For me, even testing it, you can have credentials for less than milliseconds. For 10 milliseconds, it generates it, then the CI pipeline reads it, and then it gets automatically deleted. And it does everything for you. And it helps really good for Terraform or really big workloads when you have like Kubernetes or really stuff that needs, the bare metal power or the power. Remove secrets from code, repos, and CI environment variables. Personally, and I've seen it happen, for example, a developer gets his laptop stolen or something, leaves it open. They go into Vercel or something, and you can see the tokens, you can see stuff like that. This basically removes everything from the pipeline, everything. All the secrets will be safe inside here, and everything will get auto-configured. And it has audit logs for compliance. Auditors love this. If you go into the enterprise, they will literally know that you have Vault and this, and they will literally pass you really fast. So also something that happened from experience is we had a developer with secret files, the code repository. The code repository encrypted this on the CI/CD, and it went on the pipeline. But what happens the developer didn't have access to the production database password due to security stuff, due to compliance, due to how leadership is structured. He simply, on the files of the code base where the lines are, he added like console logs or stuff like that to extract all that and get access to the password and leak it. So that's also that you can have inside I know he was crazy, but yeah, if you're watching me, I forgive you. But it ended up being a lot of work or whatever, but sometimes the attacks can come from the inside. So this fixes all of that because you don't need an infrastructure team, but everything will be handled for you and everything will be like kind of secret, secure. So that's why we also went this route. And this is basically also like what Vault does. It works with any cloud, with Azure, Google Cloud, with Kubernetes, directly with GitHub. So you got a lot of that. And you can even store databases inside of it. So more like imagine Mongo, imagine Firebase. I personally like Firebase a lot. It's very similar. SSH keys and even OTP passwords if you need to generate all of that. It handles everything kind of automatically with you and it syncs with everything. And all of this is with the free version. For the enterprise, you just need compliance or higher quotas. That's what you get, or you need support. And they're very generous, honestly. So I was like, okay. And last but not least is Veeam. But basically what this does is back up all of this into an RDS instance that is ransomware resistant automatically and basically backups everything. So it's a neat product, honestly. It takes a while to configure or to synchronize. So maybe we just fire the event and it will take around 30 minutes to do, but it's like the last piece of the puzzle, like full backup of the backup of the backup. So this is basically the diagram of what we're gonna do right now. So you have your code here and we have Vault access code. The Vault will literally read all the secrets and then it will either send them to GitHub, send them to AWS, and then Veeam will create a database instance and save it. And everything like of that will be parallel to the CI/CD process that is used by Terraform. So everything running in parallel or running separate gives us the security and the not headache that we need. And honestly, it's super easy. So this is the demo that we're gonna do. I'm really hoping, praying that everything works perfectly. So AWS, but we're gonna run Terraform locally. I already configured an AWS Sandbox account, and then we're gonna see if Veeam, Terraform provider. So the first thing that I wanted to show is once you are in AWS, you need to create an IAM user and attach the policies. For example, I attached the RDS full access so it can create, delete, configure an RDS instance on MySQL or basically anything, and I added administrator access so it can create other users. Basically, that's the only thing you need. This will download a CSV that will have the access key and the access secret, and that's what you need to configure on the AWS. But this is basically everything that we need here. And just as a disclaimer, for example, you can, in DigitalOcean, you have a one-click deploy of HashiCorp Vault. So it's fairly easy. You don't need to configure anything. You just create an instance, and everything is pre-configured by you. But starting with the demo. So I'm gonna create a new terminal, new window. Perfect. Let's make it bigger, like a lot bigger. And I have my notes here. So yeah, the first thing that I have running locally is Vault. So I'm gonna check it's actually running Vault version. So we have Vault version. This is the open source one, and you can see was recently updated, so that's pretty good. And the next thing is I need to see if Terraform is running. So I'm gonna go on version, and yeah, we have Terraform running. So that's great. So the first thing, I'm gonna start the Vault server. So it's literally running Vault server dev. Oh my gosh, already in use. Interesting. So let me just go ahead and close all the terminals, run them again. And let me see if it's actually running here. Okay, it was already running. That's interesting. The thing is that Vault, I think, is process kill Vault. Let's just try to see if we can get the token here. Okay, so that was a setup. Basically, a setback. Vault creates a UI for you so you can access it, but I need the token that it actually outputs. So, let's see if the fastest thing would be to restart. So let's see if we can do that right now. But I have a lot of stuff. Oh. Sorry, please bear with me, guys. Let me see what else. That's actually a great suggestion. Thank you. Let's see if this is has something that is still running. Yes, it is. Thank you, sir. Appreciate it. And let me force quit it. And let's go ahead and run a terminal. There we go. So thank you so much. So this is the first thing that we need to run. We basically are running Vault in a dev environment sandbox that as soon as you close it, it's gonna close everything and basically delete everything. So this is something that generates on the first run that is root token and an unsealed key. The unsealed key, basically what I've seen companies do is they just put it on an envelope and they put it like on a safeguard because it's like the master key. But this is the one we need. So let's go ahead here and reload. And this is the token we can use to access. So we can use Vault either through the CLI or through the web interface. So this is just the normal web interface. We create two places like the secret and cubbyhole, and you can then have access, the policies, have a lot of stuff. But let's just focus right now and create a new what do you call? Terminal. So I need to paste this because we're gonna export our global Vault instance, and then we need to export the Vault token, which is what we're gonna use so Terraform can actually see it. So let me go here, copy this, and let's have it. Okay, perfect. So that way, in the new terminal, we had that. And how do we store the secret? So we can use the UI, or we can literally just run commands. And let's do Vault kv put. And which database are we gonna do? We're gonna use the secret DB, and let's call it password. This is the password that we're gonna use to create the RDS instance. So let's go password equal my secure pass. And let's go with commit your code. Perfect. As you can see, here we just created it. And this is something important. It has a creation time, a deletion time. You can have tokens that expire automatically that are destroyed after certain access, and you can add any custom metadata. I personally always add who created the token, what is somebody doing, etc. And what if we need to get it? We just go Vault kv get secret, the access that we got DB. And this is how it's stored. And in the UI, we go into a secret, and here you can see it. It actually ended up creating it. You can see it here as an admin. As you can see, we're here, whatever. So moving on, the first thing that we're gonna do is actually our Terraform thing. So I'm gonna be here, gonna go into documents, Menkadir demo. Let's go into demo, and let me go ahead and let's go and create a initialize Git. I personally like initializing Git so we can actually, keep track of our changes. And then let's send this to Visual Studio. There it is. So we can kind of have it. So really fast, because we have 5 minutes, I'm just gonna create 2 files. I'm gonna create the main, let me create main.tf. This is a pet peeve. I call it like this, so it ends up saving it. And I'm gonna create another file that I'm gonna create that is called Terraform, terraform.tf-vars. Basically, those are the 2 files that we need to create our Terraform configuration. So I have this honestly, that I'm just gonna go ahead and copy paste it and explain a little bit. This is basically Terraform. You declare your infrastructure just with code. So the first thing is we need a variable that is gonna save from our storage the variable, the token that we need. So we declare here we're gonna say to Terraform, imagine the package.json that we have on front end. We're gonna say, hey, we need AWS and we need Vault. So we need you to install that. Then the provider, we're gonna deploy this on ES1. We can adjust it to any region. This is the Vault, so we're putting the server. If you guys see, if we click on this, it's the local server that we're running. And you are gonna need to take this, the Vault token. It takes the secret from the Vault. I'm gonna put this all in a blog post so you guys can just copy paste it or run this again. And this is where we declare. I need you to create an AWS instance that has 20 gigabytes of disk. MySQL is a dbt3 micro with admin, and here is when we inject the password. As you see, we're not having anywhere any password. It's gonna read from the Vault and put it, and the output is if it does. And the only thing that we need to put on this file is what it needs to do. So Vault token, and we need to actually add the Vault token that we created here. So let's go ahead and do that. And that's it. Literally, that's what we needed. So the first thing that we can do to run this is go Terraform init. Oh, Terraform init. Now it's gonna go ahead and find, it's installing HashiCorp AWS, it's gonna install HashiCorp Vault and everything. And the next thing is gonna be literally Terraform plan. This may take a while, so I had a backup of the backup. Oh no, that was super fast. So it was just initialized. So the second thing we're gonna do is Terraform plan. And what Terraform plan is, it's like a dry run. It's gonna check if you have access to AWS, if it has access to the Vault, if it has access to everything. And look, it says literally, you have access to everything. You can create this, everything. This will be created. And if you wanted to create it, you just go Terraform apply, and that's it. It says, do you want to perform these actions? It's gonna create this. So yes. And woo, we had an error of access denied. Okay, so then we will need to go into IAM console, see why we got error denied if we added the RDS access, and basically it will automatically create. So just to wrap up, as you can see, it's very easy to create something. What I want to reiterate is this is literally the code you need to configure the Vault, and this is the code that you need to configure Veeam. As you see, we literally just add a provider. On an endpoint, this will be the URL from the actual URL from database that will be created on the previous step, and then the resource policy, and that's it. Everything will be automatically configured to you. The only thing that we will need to change on this Terraform plan or code is how long we want the backups. So I will go here and basically just tell it, hey, I need you to back up daily RDS at the schedule every time at 5 UTC and keep after 14 days. And this will do everything for you. And that's it. This way you have secrets, you have backup of the secrets, and it just works and deploys with one terminal command. So that's pretty much it. So just to wrap up, because I have 1 minute, the best practices would be never hard code secrets in Terraform. Use this. Store Terraform state securely. You can save your Terraform configurations to S3, DynamoDB log. This is like a really secure way to do it. If you want like major security for any compliance stuff, use least privilege IAM roles. As you see, the error I got was because of IAM policy, because I have the least privilege principle globally on this AWS account, and test restores, not just backups. So that will be the last thing. Always test restores. And yeah, that's the wrap up. We did infrastructure as code, secret backups. The next thing will be try it in a sandbox and then scale it to production. You can do it with your own home server. Your personal website will be an awesome thing. You can host it for less than $3 per month on AWS. And that's it. Thank you so much, guys. If you ever want, thank you. If you want to connect, this is my Twitter, this is my GitHub, and whatever questions you guys have, I always follow back everyone, and we can just talk. and we're here to help. And that's it. Thank you, guys.